Let's talk about logarithm equations. There, our unknown x is inside some logarithms. Maybe inside one logarithm or inside many logarithms. How can we solve these equations? Because the logarithm and the exponential function, they are inverse functions, we can write this number 2 here in the right hand side as natural logarithm of e to power 2. Here the natural logarithm and the exponential function, they would cancel out and give us 2. So now we get that for these logarithms to be equal, their arguments need to be the same. So x plus 1 needs to be e to power 2. So x needs to be e to power 2 minus 1. In the next equation, the x is inside two logarithms. At first we need to combine the logarithms. So let's shift the other logarithm to the left hand side. And let's remember the rule of logarithms that a logarithm of a product is the sum of logarithms, and the logarithm of a division, it's the difference of logarithms. And here the logarithms can have any base. For any base this works. So now we can combine these logarithms in the left to give that there is just one logarithm of 2x plus 3 divided by 3x and this equal to 1. We can here set both sides to the power of e. We would have e to this power is equal to e to power 1. In the left hand side, the e and the logarithm, they cancel out, so we are left with a equation. These were two examples of logarithm equations. The main point was that somehow we can get rid of the logarithm. We can find that the arguments of logarithms, they need to be the same, and we get an ordinary equation. Or after combining the logarithms, we need to do some operation to be able to get the equation without logarithms. Well, in the second example, we could still solve this normal equation. Let's multiply both sides with 3x. We want to solve for x, so let's move everything with x to the left hand side. And all other things to the right hand side. Let's take x as a common factor. Now, because e is here about 2.7, we recognize that this number here is negative. So it might seem smart to flip it around So let's multiply both sides with -1. Now we can flip the number in the left hand side, and in the right hand side we get 3, and this is a positive number. We get that x is 3 divided by this number. My calculator tells that this number is about 0.49, and it seems reasonable. If x is 0.49, then both of these numbers here are positive. So everything might work out. If I would have got that x would be negative and very small negative number, then the logarithms would have not been defined. We have that logarithms are defined when x is positive. These were 2 examples of logarithm equations.